Welcome to a new test and teardown video. This time it's a radiometer, a signal generator type MS4, and this one has serial number 395. It is a very old unit. As far as I know, there is only one more known unit like this in Denmark, and the guy who owns this has been requesting schematics or information about this unit for 2 years and still haven't found anything at all. So there's not a lot of info about these units online or at anybody's. So the frequency ranges. So that this område, that means ranges. So you select one of 4 ranges, and here you see this little 1, 2, 3, and 4. So if I want to make 1 kilohertz, range 3. Yeah, okay, we are in range 3 now, I guess. This is a very fragile, like a little needle pointer here, and that's not broken, so that's really cool. This is milled brass. Nice. On later versions like the MM1 and so, they still use this exactly this design, but it's of course made of bakelite. Also here it's brass. Antenna spinning, that means antenna voltage. So I guess this is the voltage that goes out on the antenna connector if you're using the antenna connector, right? I still haven't figured out exactly what 100 per watt per... what is that? And then we got some voltage here. So you can select between 200 volts or 20 volts output. LF and... what is LF and then output? I mean... is that also an output, or is it... I don't know exactly what that is. I got this at a flea market for 0 money, so it was just a pick it up, you take it home, and we'll be happy. So that's quite cool. I hope there's something inside this unit, because mains power was cut. So we need to open this big and heavy unit. So that's actually quite nice. Finger nuts. Easy. Let's get in. That is very lucky. I mean, we got stuff in here. I thought the mains power cord was cut. Well, that is not the case. Oh, there is a terrible smell in here. Somebody was messing around with this. So there's this funny connector. Where's that going? What exactly is this? That is some kind of a special modification. Let's try and unscrew. How's that done? Now see what that is. Some sort of a mains filter or mains power supply or some stuff. I mean, this is mains input, and then it goes to a mains filter of some sort down here, right? So it goes up here, and then some part is missing. And then what exactly is this? What that is. Look at that. So mains input, fuse, and some part. We don't know what that is. Probably just some power resistors or something, right? And then a rectifier. But look at that. The rectifier is... no, it is connected correctly. So that will be the AC going to that and that one up there. Okay, AC. So the positive of the output goes to this capacitor. And another little, and it says even positive here, right? So if you look a little bit closer in here, look here, we got a very big high voltage anode battery, and down here we got a smaller filament battery. So this will be the filament voltage and this will be the anode voltage. So this is what it's doing. So the anode voltage goes down here and then it goes also out here. So the red one is the anode voltage and the black one, that is the chassis. So all you have to do is put in a filament battery here and we'll be good to go. So this one was initially designed to run off batteries. I think that is how I figure this out. Also, note that the chassis here is one piece that goes all the way around the unit. So it's not really easy to do service here, right? We need to take this entire thing out somehow if we want to do any service. Maybe we can take off the bottom and look underneath, but we can't see inside the tuner. That is a little bit annoying. So that is a closer, close up of the anode supply on this transformer. I don't know if we're able to see more clearly what I'm doing here, because it's just so maybe I can help somebody else in the future how to power this up. So how much anode voltage is this? Probably just 90 volts, right? And filament voltage is, yeah, let's look up the tubes. Both of the tubes, they are DL21. That's a beautiful power pentode. And if you look this tube up, you'll find its filament voltage is 1.4 volts and recommended anode voltage is 90 volts. So I bet that is more or less what the batteries they should supply, right? And this is what I will go for. Let's see if something happens, right? One more thing to mention. When you pull tubes like this from their sockets, don't grab the glass. Never ever do that. In fact, don't touch the glass if you can avoid it, because you're gonna rub away the text. And also, see what happens. See? They get loose. And then if you pull here, you can break the thin wires down here, right? Always grab the socket and then carefully wiggle it like this while you're pulling. Then it's gonna go okay. Now I need to re-glue this one. That was interesting. I removed the bottom, and of course they removed paint all the way around to create a good shield. That will be the output attenuator. But look at that. The wire in the middle is rotating. How funny is that? So there's a slider in here, or actually multiple sliders. It definitely feels like that. And then there's a capacitor across the output. That's also a little bit interesting. And that will be the 4 bands. So maybe we can have a look in here as well. And we also got some notes. This I will have to see if I can make a good picture of. So this is the bottom plate underneath the 2 tubes. I thought those holes, they were for ventilation, but that's of course to access the trimmers for frequency alignment. That will be the different frequency ranges. I am a little bit confused about 4 ranges and only 3 sets of inductors capacitors here, so maybe one of the ranges isn't installed. And there's also a really cool inductor here. I don't know if you see this splatty splat here from that capacitor. Is that the one that made us splat here? I don't know. Could also be some of the splat from this one, right? And then there's a little room here. I think this is where you can hide your pot. So I took away the top as well. This way I can see inside this room. And also I saw Accu Plus, but this should of course say filament Accu. And there's another thing that I figured out is this is the, of course, the filament Accu connector, and that wire is the only wire that goes through the on-off switch. So that means the anode supply is not going to a switch or anything. So that is on all the time. So when there's filament, there's also current on the anode. So that's probably why you don't need a switch on anode supply. All right. So inside this little room here, that is the output section. And look at that super cool. It's called super electric condenser. Oh, all this is really, really old stuff. 1940s rectifier for the meter. That will be 4 selenium diodes in a bridge. I turned off the light here, so let's see if we can see the filament. But I think we cannot really. And I also think I know the explanation for that. Both of these tubes, they are 1.4 volts, about 50 milliamps filament, according to the data sheet. I also see some coils and stuff like that over here. So that means we got voltage drop. So maybe I should give it 1.5 volts. And the current consumption is 80 milliamps for 2 tubes. And of course I tried to pull one of the tubes and then I got exactly half. So that means I am lucky I got filament in both of them. The reason why we don't see a lot of light in the filament in those tubes, that's because it's made to be super efficient, battery powered. So everything in here around the filament and the cathode and all that is made really small. So you shouldn't really see anything. But I bet it's there. Just cannot see it. Well, that is a disappointment. I love the nice glow of tubes. I've been running with filament on those 2 tubes for 2 hours now. And look at that. I mean, it's not even visible. Well, maybe it is a little bit visible on a thermal camera, but it's this just say a little bit about how little power we're talking about here, and this is essential for battery operated equipment. Very impressive. And what have we got here? We got output. This thing actually works. And here we go. 30 plus 32 plus 30, so that is very close to 90. And that will be my filament. Maybe my filament is a little bit high. Let's try and go down to 1.4 and see if that still works. So that was 30. Let's go also on this one. Let's go also 30. So that means we got 90 exactly, right? So that is the output. And let's try and... Oh, I'm so sorry about this shaky camera here. Let's try and dial. So that's the output frequency. Definitely. And if I take the... Where's the button? Here's the knob for the different bands. See? So that works too. And I figured out this knob, it says 400 per. I don't know exactly what that translates to, but that is output. Weird. So yeah, it is back to life and it actually works. How about that? And it looks like this meter is not showing anything because that output is not working. It's not in use. So as you see, it will measure current, right? I need to have a connection because, ooh, be careful here because it's a 200 volt output or a 20 volt output. So you need to be careful here. Somebody's been running this a little bit warm. So I'm quite happy. It's actually working, this good old signal generator from 1940 something. I just moved it a little bit around, I think. Let me see if I can get a better picture of what I'm doing here. See? Of course, maybe you need to change a little bit of capacitors in here, and that's very resonant. So that is 300 kilohertz. So now I turned it off, and like I said previous in the video, anode voltage isn't disconnected by this switch. So anode voltage is still connected. By the way, this is an offset in my power supply. It will say exactly the same if I remove the wires. So I didn't zero this. This is a fault that happened after I blew up this power supply. This one works because I didn't blow up that one. So 0 milliamps. So far so good. Now I will try and turn on the unit. And there's output immediately. Isn't it just amazing? I think this is maybe a direct heated cathode. It gotta be like that, because otherwise, how is it possible to be that fast? See? The cooldown is a quarter of a second. I mean, that is amazing. And it turns on. Listen to the click and then look at the output. Really? That gotta be direct heated. I need to look a little bit deeper into the data sheet of DL21. Reading around in the data sheet of DL21, and I can't find anywhere where they explain if the filament is direct or indirectly heated. Well, they do talk about the warm-up period of about 0.01 seconds. Really impressive.